Welcome to this session, Attention Contention. Thanks to past organization for giving us this opportunity to deliver this session. It's an honor for us to be here. Please remember to evaluate this session. It's very, very important for us and also for the past organization. My name is José Manuel Jurado. I am escalation engineer working in Microsoft. I belong to the group of Azure SQL Database support team. I'm a speaker in different events, public events or internal Microsoft events. Let me to introduce my colleague, Juan.
Hello, this is Juan Moreno. I'm support escalation engineer at Microsoft. I'm based in Madrid, Spain, and I belong to the Azure SQL Server hybrid team. That means that I support SQL Server on premises. I'm also a speaker at different events from the community and from Microsoft. And today, this is our agenda. We will talk about a well-known performance issue. It is tempdb contention. For some of you, this is something that sounds familiar. And in this session, we will try to analyze both kinds of contention, allocation and metadata contention. And we will try to show you when and how it occurs, how to diagnose it, and how to prevent and fix it when available.
Let's start the show from the beginning.
Okay, so imagine that you have an application, a very easy application that runs this query. It's a very simple query where we just insert 50 records into a temporary table that we have created just before. And then we drop that table. When we have a few people coming into the office, let's say 2 or 3 people, just to say something, okay, we see that our query runs very fast, okay? It only lasts 17 seconds and create all this stuff. But then the DBA start to see these kind of things, a lot of threads suspended, okay? And then we realize that we have more people at the office, okay? So attention with this, because the performance get impacted. As you can see, now the time is larger than at the very beginning of the morning. And according to the people get to start at the office, okay, according to we have more and more people, what we will see is that this query will last a lot more than before, okay? This, my friends, is contention. So Jose Manuel will show you now how it happens in the real life. Let's go with the first demo.
Thanks, Juan. In order to simulate this situation, I have this example application that you could see that I'm going to run a number of threads, okay? I'm going to create 2 threads per core. Every thread will run automatically around 100 operations. In these operations, it's to run, as Juan mentioned before in this example, this query. One second is here. You can see we are going to create a table. We are going to insert data, and that's it. Okay. So I'm going to run right now this application. Suppose that it's very early in the morning. You have a few clients, customers, or clients in this case, running this query or running this process, as you can see here. We create this one. I'm going to the SQL Server, and we are going to run right now this point. This query, it's very important. It's just only to show you several details about what happened. Okay, we don't have any issue in terms of blocking, in terms of any other issues.
So we have no wait here.
Yeah. So I think that, okay, what's finished? Right now, Juan, as you could see, this process took around 23 seconds to be completed, okay? So as Juan mentioned before, we are going to simulate that we have more people in the office, okay, using our system. For the reason, I'm going to increase the number of threads per core, okay? I'm going to change this value to per 8, for example. And we are going to do the same operation, the same 100 operations per thread, using the same query that I showed you before, okay? So let's try to do it and run the application.
So now we will have 64 threads, isn't it?
Yes, this is the number. Okay, right now it's running. Let's go to the SQL Server. We are going to run the same query that we did before. Oh, we have something special here, Juan, not?
Yeah, I can see it. So can you show me how is the status of the threads that we have? Because I see that most of them are suspended, not running. Oh, look at that wait type.
Is payloads up?
Yep.
And it's a strain, not Juan?
And
Or
also
is it
the wait resource is very curious, isn't it?
Yes, it's very curious. Yes, Ryan. Yes.
Okay, can you go to the beginning of that way? Okay, so as we can see, most of the threads are suspended, are waiting, okay, and just a couple of them are running, okay?
So it's the same application, the same code, the same application, just only we increase the number, okay? The concurrent operations, okay?
Okay, so we have seen in real what we have seen before in the previous slide.
Let's go to the application, okay? As you could see, the application was completed in 1 minute and 28 seconds.
Oh, that's much more longer than before. So yeah, we have a performance impact here. Okay, so what we have here is tempdb contention. Actually, tempdb contention are two different topics, allocation contention and metadata contention. We will see both of them in the following slides. So let's start with the allocation contention. Allocation contention is what we have just seen in the demo that Jose Manuel has done. So when does it happen? Well, you will see allocation contention when you create multiple temporal objects as the temporary tables that we have created in a concurrent way. And that is the main point. We need concurrence to have allocation contention. Otherwise, you will not see it. That's why we create several threads against our cores, okay? So when you have repetitive create and drop operations on temporary tables, okay, it doesn't matter if they are local or global, you will see this kind of allocation contention. Also, when you have table variables that you use tempdb for storage, you will see it. When you have work tables that are associated with certain cursors, you also will be able to see it. And when you use work tables that are associated with an order by clause, you will see it. Why? Because we use tempdb to store it, okay? And also when we have group by clauses. So all of these points allow us to create allocation contention because we intensively use tempdb.
Right now, I think that I could understand right now what happened with the application, right? So in the beginning, we have just only 16 threads running in concurrent way, creating and deleting tables. And right now, when we have more, we have allocation contention, right?
Yeah, exactly. Okay. We are using intensively tempdb because we are creating a temporary table. That means that we are using tempdb, and we are inserting a lot of records on that in a concurrent way on that temporary table. And then we drop it, okay? So the main issue that caused this issue is that we are inserting on that temporary table a lot of records in a concurrent way.
So the problem is that the problem is the tempdb.
Well, with the problem is in the tempdb. It's not the tempdb itself, it's in the tempdb. So let's see why it happens, okay?
Okay.
It occurs because of the way we need to allocate all these records that we are inserting, okay? We have something that is called PFS, okay, page free space. And this page free space is the page number 1 on our file, on our tempdb file. The page 0 is the header, the page 1 is the PFS, the page 2 is the GAM, and the page 3 is the SGAM. Later we will see what is GAM and SGAM. Now let's focus on the page free space. The PFS is the page that we need to check when we try to allocate something, a new record, a new object in tempdb. We check for that page in order to see if we have free space. What is the next free space that we have? So we will go here, okay? Then we will use also, we will not go so deep, but we will use also GAM page and SGAM page. So these 2 pages are the most important ones for allocation contention, are the ones that will create that allocation contention. How can we diagnose it? How can we realize about the tempdb contention? Well, it's very easy, very, very easy. The first symptom that you will see, as you have shown in the demo, is that we have a worse performance. Okay,
yes,
so we will have.
For example, this is the time that one process took just only 25 seconds, and right now we have more than 1 minute, right?
Exactly, exactly, and we will see why. We will need to wait, and as we have seen in your demo, what we will see is that we have page latch waits, and we will see it on a tempdb resource. How we determine that we have a tempdb resource? Well, because we will see mainly page latch up and page latch shared, update and shared on this kind of resources, 2x, 1, 2x, 3, or 2x and multiples of 8088, okay? X means the file of the tempdb where we have the allocation contention, where we have this page latch, this weight. Is the tempdb ID, okay? X is the file of the tempdb, and the number 1, as we have seen before, is the page for PFS. The number 3 is the page for SGAM, okay? And multiples of 8088 will be PFS page.
I have a question for you right now. So you mentioned that this contention, let's say, if I understood well, it's based of different tempdb files, right? So what happened if I create more files in my tempdb?
Let me show it to you.
Okay.
And that will allow us to fix it once we have the contention, or to prevent it, so we will not see it, okay? So the recommendation, the best practice, is to create multiple tempdb files, not just one. Currently, the installation, the setup of the SQL Server creates by default different number of files, okay? Usually 8 tempdb data files, depending on the logical cores that you have. And again, I repeat, logical cores, okay? So if we have up to 8 logical cores, the recommendation, the best practice, is to create 1 file per logical core. If we have more than 8 logical cores, then we will evaluate the contention, okay? We will start with 8 tempdb files, and if needed, if we see that we have contention, okay, then we will increase the file number 4 files each time, but with careful. This doesn't mean that you will create 64 files. So we will start with 8 logical files, or as many files as logical cores if we are up to 8 logical cores. How it works, and you will see now very easy how we will work. Imagine that we have only 1 file here. What we will do is we will have 1 PFS page that will cover 8088 pages. That means about 64 megabytes. So we will have 1 PFS page per 64 megabytes. Okay, so if our tempdb file has 128 megabytes, we will have 2 PVS pages. These sections are managed by each PVS page. So one PVS page will be able to manage up to 64 megabytes of pages, up to 88 pages. Once you have created it on each PVS, you will have these bytes, okay? That means where we have a ghost record, where we have an allocated page or not, and all the information for this block, okay? For this section, for the PVs. Then we have the GAM page. GAM page and SCAM page will manage other kind of information, and we will manage about 64,000 extents, okay, for each page. That means that we will have one GAM page and one SCAM page, each 4 gigabytes. So if our file is less than 4 gigabytes, we will have only one GAM and one SCAM page. But if we have a file with 8 gigabytes, we will have 2 GAM, 2 SCAM pages. So this is the architecture of our file. This is the structure of our file at tempdb. So what happens when we have only one file? That we need to access to this PVS page and to these GAM SCAM pages to allocate each record or each object that we create over that tempdb. Okay, so the problem is that all the threads are trying to access this PVS page or this GAM or SCAM page. What happens when we create several files of tempdb? What we will do, what SQL Server will do, is that the first thread will request this PVS page for an allocation. Okay, the second thread will go to this PVS page and will allocate here. The third one will go to the third file, this PVS, and to this, and will allocate on this section. And the next thread will do properly with this file. What happens now if we have a fifth thread, like in our example that we have 8 threads? Ideal, we will use the second PFS page section to allocate the next one. But what happens is that we continue using the first one, okay, in the different files, but we continue using the first one. So we continue seeing less allocation contention, but we continue seeing allocation contention if we have a lot of threads. What we have done is that we also have created a round robin between the PVS page inside one file. So we have fixed it in Service Pack 3 for SQL Server 2014, in Cumulative Update 9 for SQL Server 2016 SP1, Cumulative Update 1 for SQL Server 2016 Service Pack 2, and Cumulative Update 7 for SQL Server 2017. So we will allocate here. In the next file, we will go to this one, and to this one. And this is very important. And now we will see that it's very important to have all the files with the same size, because in that case, we will have the same number of PVAs and GAM and SCAM pages, and also the same grow algorithm, okay? So if we set this to grow in a fixed number of megabytes, we will set all the files to grow in the same way. If we set here a percentage, we will set all the files with the same set.
So beside this best practice one, you mentioned growth, but the same growth size, the same size, etc. Start thinking that most probably other best practice, as you mentioned before, is to have more than one tempdb file, right? So in terms of tempdb, for many files that we have, we are going to have less, let's say, less contention, right? Based on this example. Okay.
Exactly. So sometimes depending on the size of the files, we have only one GAM or one SCAM page. Sometimes we continue seeing allocation contention, but not in PFS page, but in SCAM page. Okay. When we saw that kind of allocation contention, what we need to do is to enable the trace flag 1118. So these trace flags modify the way we allocate the objects. To better explain how trace flag 1118 works, let me explain first how we use SGAM page, the shared global allocation map page, on SQL Server. SGAM pages are used to track if an extent is mixed or not. But most probably, now you are wondering what an extent is. Let me explain in a few words what an extent is. Extents are the basic unit that we use to manage space in SQL Server. An extent consists in 8 contiguous pages. That means that we have 64 kilobytes per extent. Remember that in SQL Server, each page has 8 kilobytes. So when SQL Server tries to allocate in space, it tends to be very efficient. So we do not allocate a whole extent with a small amount of data, with a small object, okay? For it, we use mixed extents. So when we have objects that are larger than 8 kilobytes, we tend to use one extent that we call uniform extents. And when we have small objects, we tend to use mixed extents. So these are the two types that extents that we have. Uniform extents that are owned only by one object. All the extent pages are used only by this object. And we have mixed extents where we have up to 8 objects. Okay, each object of this, each page of this extent can be owned by a different object. What trace flag 118 does is to force SQL Server to always use uniform extents to allocate objects. That means that we will need to check very, very, very few times the SGAM page for mixed extents to locate free space. This will allow us to be more efficient when we try to look for a space. So we reduce the allocation contention in this way.
So based on this this information, Juan, so that means that if I enable this trace flag, means that I'm going to use more space that I need in tempdb?
Yes, yes, because we will not be so efficient, because we will create, we will use the whole extent, 64 kilobytes, for an object that maybe only use 1 page or 2 pages of that extent. But in the other hand, we will have a more fast way to allocate this object. Okay, so we will not see, or we will reduce the possibility of have metadata contention over SGAM pages. Okay. Also, we have another recommendation that is enabling trace flag 1117. Some people don't like to use this trace flag because this trace flag forces SQL Server to enlarge, to modify the size of the files in the same way. That means that if one of the tempdb files grow, all the rest of the files will grow in the same way at the same time. Okay. The problem is that, is that all the databases are affected by this trace flag, not only tempdb. So if you enable this trace flag, you need to be sure that all the databases have enough space to allow all the files that they will have to grow in the same way at the same time. Okay, so these trace flags are needed to be enabled up to SQL Server 2014. If you are on SQL Server 2016 or 17 or 19, you will have this behavior by default. Okay, so not need to enable the trace flag 1118 or the 1117. Okay, so Jose Manuel, go ahead and show us the demo for this part.
Yes, thank you, Juan. So previously, I would like to show you what happened. What was the main issue that we have about the allocation contention that Juan mentioned before in previous slides? We have two SQL instances, as you could see here in the properties of the tempdb that we test previously our application. You could see that we have the number of files is just only one. This is the main issue that we have. We are not following the best practice, the recommendation that we have previously, and right now is just only one file. So I have another SQL instance, as you can see here. So following the best practice about to have the same number of files with the same number of cores that I have in my SQL instance. As you can see, we have 8 with the same size, with the same growth, etc. So I'm going to right now run the application, and we are going to see how much time took and if we are able to see if we have any allocation contention. Okay, so let's go to the application. I changed right now the condition string. I'm going to use the same number of threads per core. Okay, the same query, etc. I'm going to run it. Okay, let's see what happened. What do you think, Juan, will be happen?
I think it will be very hard to see any allocation contention if we see any.
Okay. So let's wait for the creation of these 64 threads. Okay, let's run the query. Okay, Juan, as you could see here, we don't have any allocation contentions right now that we have previously, right? So we could run multiple times this query. As you could see, we don't have. So it seems that it's true, Juan. It seems that when we follow up the best practice in terms of files, the trace flag, if we are using SQL Server 2014, etc., we are not able to have.
It's a kind of magic, isn't it?
Yes, it's kind of magic.
And it's running the query. It's or it has already finished.
Let me check. Yeah. Oh.
Okay. Wow. 17 seconds. So it's very fast with 8 threads. Amazing, isn't it?
Yes, right. It's true. So at the end, I remember that using just only one file, we had previously around 1 minute and 25, something like this.
Yeah, something like that.
And right now was just only 17. Wow, it's a very huge improvement, Juan. Well done.
Yes.
Thank you so much for this recommendation.
But remember, this is because we have SQL Server 2016 forward, because otherwise we should need to enable the trace flag 1118.
Okay, great. Great to know. So
perfect. Thank you. So let's continue. Okay, Jose Manuel. So thank you for that demo. Let's go now with the next topic, the next kind of contention that we have on tempdb.
You know that I'm very happy right now. My application is running very fast. Juan, thank you so much for these instructions. Thank you so much for the recommendations.
You're welcome. You're welcome. Okay, so the next topic is a different kind of contention, but it also affects tempdb. This kind of contention is the DDL or metadata contention. What happened here? When metadata contention happens, okay, when we talk about metadata contention, what we are talking is about contention on system objects in tempdb. Okay, we use these system objects to track what is happening on the temp tables. Okay, so when we use concurrently, again, the most important thing here is concurrency. When we try to track multiple objects in a concurrent way on tempdb tables, we will face this metadata contention. So just to know how it works, imagine that we have a temporary table with just 10 columns. Okay, it's not a big structure for a tempdb, just 10 columns. When we create this object, we create one record for the temporary table itself, for the object. And we need to insert this table in a system table that will store all the metadata for these kind of tables. Okay, and now we have 10 columns. That means that we will create one record, one row per each column we have on that table. Okay, so we will need to save one record that will represent each column of this temporary table. So in total, we will need to save 11 records in this system table. And we will have a system object that will be managing all this kind of stuff. In the same way, when we dispose this table, when we finish to use this table, we will need to drop this element. We will need to remove this element. What happened? In a more easy way to understand it, if you see this graphic, what we will do is, okay, we have 3 nodes, 3 cores, okay? So we will have 4 threads per node, and we will see that we have all of these threads drop in our table. And we will attack the same object, sys object values, in order to delete these records. And this is what will create contention. Because we will wait, we will have a latch on this object, and we will wait till this object can accept the next request. Okay, so what happened here? How we can diagnose it? Well, it's a little bit more difficult than the other one. What you will see is that we have page latch also, but if you remember, we see page latch update and page latch shared when we have allocation contention. But when we have metadata contention, we used to see page latch in exclusive mode. So you can use this query to see what kind of page latch do you have. And the most important thing, you will see that it is on tempdb, on whatever the file. And now it will not be 1, 2, or 3, the page. It will not be 8088 multiple, because we will now have a data page, okay? Because what we are doing is we are blocking a specific object, okay? So also, if you run perfmon, you can check what is the timetables creation rate, or what are the timetables for destruction. And if you see these numbers very high, you also can suspect about metadata contention. Metadata contention, as allocation contention, will create performance issues. How to fix, how to prevent this issue? Well, it's not as easy as the allocation contention. So in this case, most probably you will need to improve your code. Also, if you run, instead of directly the SQL code, you run the code, the creation of these temporary tables from a store procedure, you will use the SQL Server cache. So you will not be continuously creating and destroying an object. And this will minimize the impact on the metadata contention. Also, I know that this is something that you could say, hey, you are pushing me to upgrade. But we have a reason. In 2017 and 2019, we have a new algorithm. Okay, in this new algorithm, we change the way to destroy the object. So instead of being a synchronous process, we use an asynchronous process. So the latches last a lot less than previously. The other improvement that we have is that we have changed the number of threads that we have to 1 per NUMA node. And also we have increased the number of tables that we remove with each pass, okay? So now we can remove more tables, and we have only just 1 thread per NUMA node. The third optimization that we have is in regards to the latching strategy. Before, we used to get the latch for all the process. Now with the new algorithm, what we do is we just get the latch in an exclusive way. Is we need to really delete any metadata rows. So only if we found rows, we take the page latch exclusive. Otherwise, we take a page latch shared. So we can continue working in a better way. So now let's show how it works in the real world.
Thanks, Juan. So I would like to show you what is the example in order to reproduce metadata contention. So the first things I'm going to have the same environment that we have previously in terms of number in threads per core. the same number of operations, but in order to reproduce the issue, I'm going to change a little bit the table. Sorry, the SQL statement. The SQL statement in this case, I'm going to reduce the number of rows that I use in order to create this temp table, and also I'm going to change the size of the destination, the table destination that I have. What is the reason about it? The reason is I would like to try to create and delete more frequently the temporal tables that I have in my tempdb. Okay, so let me just only modify one thing that I forgot. It's to mention to my application that please reproduce the issue using metadata.
Okay, so we will increase the rate of creation destruction of these temporary tables.
Yes, right. Yes, that is the idea. Yes, because in terms of metadata, as you mentioned perfectly before, it's I would like to create more frequently the databases with more speed. Okay, that's mean that SQL needs to, as you mentioned before, the sys objects in order to if exists or not. So we have this. I'm going to run the application. Okay, it's running. Let's wait for the computation. Let's wait for a couple of seconds more.
We are almost there.
Come on. Okay. Right. So right now I'm going to run the same query. Oh, we have something that is different, right, Juan?
Yes.
So
we can see again suspended threads. Okay, but now what we see is that we do not have PCS, scam, or scam contention. Okay, we have that kind of page, the 11, that is a data page, and it means that this means that we are have Latin on these kind of sys objects. This is metadata contention. We have a lot of suspended threads waiting on a couple of them because we have these contention system objects. Can you continue executing to see?
Yes, Juan. Yes, also, as you could see, we have drop table, renable drop table, run integrate table. So we are affecting right now a lot in terms of metadata. Yep, as you can see here. Let's try to run again.
Okay, run it again. And we see that the problem is when creating and when dropping the table. So run it again, please.
Run again the query. Wow. Wow.
Okay, so yes, we can see that almost always is in drop table, create table. And if you run it again, we can see that we have different page, always data page, okay, and almost always with drop, create table, the threads that are suspended. Okay. We are stressing a lot the system objects. So this is something that we can expect. And as you see, the page latch is exclusive. So the kind of weight have changed from update or share to exclusive.
It's a very few milliseconds, as you can see, right? It's
yes.
Just only 18 milliseconds.
It's very fast, but when you have concurrent threads that are waiting in cascade, it will impact performance for sure. Okay, so it has finished, so stop it, please. Okay, Jose Manuel, so thank you so much for showing us the metadata contention. But as we have mentioned, if we use an store procedure instead of running the query directly, we will use a SQL Server cache, so we will not see this kind of metadata contention since we will reuse the object. So can you show us how it works with a store procedure, please?
Yes, for sure. This is the definition that I create following your instructions that we reviewed previously about the best practice. I'm going to use the same query that I did previously in my application without using a store procedure. You could see this is the definition, create a table, run the select, insert the data, and drop the table. It's the same query, okay? So I'm going to go back to the application. Using, as we mentioned before, using the same number of a thirst per core using the same number of operations. And I changed my application in order to run this stored procedural. As you could see, basically, it's just only run here the stored procedure that we mentioned before, that I showed you before. So let's try to run it. Let's wait for the computation of these 64 threads. And once we have this, I'm going to switch again to the SQL Server Management Studio, and we are going to see what is the impact to use this way. Instead to call add hoc query, try to run using the same query using the stored procedural. Okay, I'm going to run the same query that in order to identify the difference metadata contention, as you could see here. It seems that it's a kind of magic, not Juan? We are not able to see any contention. We have no. It's just only create a table. As you could see, we are creating the tables.
But it's running. It's not
yes,
the weights. So
yes.
it's perfect. This again is a kind of magic. All the metadata contention has disappeared. And if you continue trying to show it with those monitoring queries, we find nothing. Okay.
Even much probably, oh no, it's still running. Let me go back again.
So wonderful.
Yes. So all the instructions that you provide about the best practice works perfectly. And my congratulations for this.
And by the way, the same way we have done before, what happened in SQL Azure databases and in Managed Instance on Azure? Do we see metadata contention or not?
For sure that we are going to see, depending on the database tier and the number of operations that you have, in the similar way that you have in on-premises.
Okay, yeah, but please always consider that since Azure is running always the latest version of SQL Server, we have implemented already all those new algorithms that we mentioned before on the slide. Okay, so we have all the improvements. So it will be very difficult to see metadata contention on Azure. Of course, if you stress a lot the database, if you don't code thinking on it, you will see.
I think that you mentioned it's important to follow up the best practice. Okay, I think that in summary, I think that is a number of files. As you mentioned before about the trace flag in SQL Server 2014.
Select the correct objects,
select
SQL variables, or temporary tables.
Yes, all these things, and the end, you're going to reach one thing, is to increase the performance of the database. Okay, so this is the most important thing. So it's very important. It's very important about when you're using this type of things in terms of you create temporal tables, you need to think what is the impact in the tempdb. So it's very important to have a right or correct configuration on your tempdb. Okay.
So let's give to you some takeaway key points. Okay. For the allocation contention, what symptoms do we have, Jose Manuel?
Well, the most important thing I think is performance degradation, right, Juan?
Exactly. And we can observe also page-lat weights, page-lat of type update and shared on the resources that we show there. Okay, on tempdb resources for PFS page, SGAM page, GAM page, and also 8088 multiplus that are for PFS. What is the cause of this tempdb contention?
Well, you know that the test that we did, it's when we have a lot of requests, concurrent requests. So that's mean that is when you try to create a temporal tables, is the concurrent creation of multiple temporal objects. This is the cause of the problem.
Exactly. So when we are trying to create a lot of temporal objects in a concurrent way, we have most probably we will have allocation contention if we don't have a good configuration. So to fix or to prevent it, what we will do? Well, we will create multiple tempdb files as much as logical cores that we have in our machine, up to 8. And if we have more than 8 logical cores, then we will start with 8 tempdb files. Also, remember to upgrade to the latest service pack and CU that you have in your SQL Server in order to get advantage of the PFS round robin also, not only the tempdb file round robin, but also the PFS round robin inside the same file.
Yes, I think that the most important thing right now for customers that, for example, are using 2017 in on-premises, 2019, or SQL Azure, I think the most important thing on managed instance, for example, is create the multiple tempdb files. It's very important. Mention that in on-premise when you install you first the instance when you are installing the instance. Right now you have in the in interface in this application, there's a tab configuration. You are going to have a new option that is called how many files that you need to create in on-premises. And remember that in managed instance or SQL Azure, this number of files will be created automatically by the system. So I think that is very important to recall this message.
Exactly. And in case despite you have enabled multiple files, you continue seeing tempdb contention, then enable the trace flag 1118 if you are running versions lower than 2016. I mean 2012 and 2014, because this trace flag will change, as we have explained, the way we insert the objects, the way we manage the extents for the objects. Okay, so if you have versions later than 2014, 2016 to 2019, this behave will be enabled by default, so you don't need to do it. Also, we recommend enabling the trace flag 1117, but remember that this trace flag affects all the databases, not just tempdb. So if you enable it, you need to check that your databases can growth their files in the same way in the storage that you currently have. Okay, Jose Manuel?
It's perfect. So I think that this is the takeaway. It's very, very important.
So let's give some key points for you to take away for metadata contention. The first of all, symptoms, again, performance degradation. But in this occasion, you will have page slash of type exclusive, sometimes shared, but mostly exclusive weights on pages that are non-PFS, non-SCAM pages on tempdb. Okay, you will find in pages that are dedicated to system objects. If you use perform, you will also see significant change on the amount of timetables creation rate and timetables for destruction. If you see a lot of change here, that means that you are using a lot of objects, and this could cause this metadata contention. So, Jose Manuel, what is the cause of metadata contention?
As we saw previously, it's when you create a large number of inserts and deletes in system tables. Okay, it's when you're running multiple concurrents operations, you are creating deleting data tables in this case. So that is the main cause of the problem.
So it's not only just using those objects, but is creating and deleting the thing that is causing the problem, because we are overloading the system objects. Okay, what we do to fix or to prevent the metadata contention?
Wow, What do you think, Juan? Because it's
Wow,
it's it's very
exactly. Wow.
it's very hard. So for
Yeah,
me,
this is not an easy. So we
yes, no.
want you to remember that one of the most important things that you can do is to minimize the creation and destruction of user objects, okay? Like temporary tables or also table variables. So it's very important that you check if you are really catching the objects.
Yeah.
Remember that if you use directly the SQL sentence, you will not cache these objects, but if you just use a store procedure, you will cache it. So it will dramatically decrease the creation and destruction of the objects. So one more thing that you need to do is to review your code. If you have objects cached, but you continue seeing metadata contention, review the code. Maybe you are destroying or you are creating the objects inside a loop instead of outside the loop. And this could create a very, very big impact over the use of the system objects.
Yeah. No, and also the most important thing is try to find a balance. It's the number of objects that you are creating and deleting, and what you are doing in this situation. Is try to find a balance. Okay, it's very important because at the end you are going to have, you could have some metadata contention in some ways. Okay, but the most important thing is try to find this balance. Okay, based on your business needs. Okay.
Exactly. And remember, always remember that checking your execution plans will show you how you use these temporary objects, where are you using it, where are you creating and destroying it. So when you are in doubt, check your execution plans. So Jose Manuel, what is the last takeaway that you want to share with all our attendees?
I think that when we talk about today about contentions, remember that we have two, let's say, contentions types. One is allocation. That means that is how SQL try to find a space for your data in the tempdb. Okay, every time that you create a one table, temporal table, it's how SQL try to find this space. Okay, we talk about many things, many ways in order to fix and prevent this situation. Another one, it's metadata. Metadata means that how SQL, let's say, control the creation and the creation and the deletion, right? It's very important. It's metadata. It's how SQL try to update this metadata. And what is the cause of the contention is when, as we mentioned before, is the creation, deletion of the object, of the temporal object, and how SQL try to, let's say, to track these changes. Okay. So
Exactly, it's tracking the user object.
Yes, I think that is very important when the summary, let's say, is you need to think, okay, you need to know that it's allocation or metadata in this type of contention. I think that is it's the summary in terms of this presentation, let's say. Yeah.
So thank you so much for attending this session. Thank you so much for being here with us, isn't it, Jose Manuel?
Yes, for sure. Thank you so much for, again, as we mentioned before, thank you so much for giving us this opportunity. We are very, very, very happy. So we just hope that you learn, as I mentioned before, Juan, the best practice in the end of tempdb, and see you in another session, no, Juan?
Yes, and here you have our contact in case you need something from us. Have a nice day ahead. Bye.
So, bye.